I'm Anil Kumar, and here is a very basic question on finding maximum and minimum on an interval. I should have written absolute maximum and minimum on an interval. Now, the question here is state the reason why the maximum or minimum algorithm can or cannot be used to determine the maximum minimum values of the following functions. So let me make a correction here. It should have been absolute maximum and minimum, which we are talking about at present. Okay, so qualify this maximum minimum by absolute. Okay, 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 absolute. So sorry for this mistake. So let me read this question once again. So we are looking for absolute maximum and minimum on an interval. State the reason why the absolute maximum minimum algorithm can or cannot be used to determine absolute maximum and or minimum, I should use both, values of the following functions. So it is all absolute maximum minimums which we are talking about, correct? So let me tell you what is absolute maximum minimum. For example, if I have a function which starts from here and kind of goes like this, in that case, this is the absolute minimum, that is absolute maximum. These two are local maximum and minimum. So that is how there is a difference between the two. Okay, now I think the question is very clear. So the question is, you need to figure out whether you can find absolute maximum or minimum for these functions or not using the algorithm. Okay, so we'll talk about the algorithm also. After all, what is the algorithm? Now, algorithm has a couple of parts, mainly three different parts. First is that the function f of x should be continuous in the domain, right? So in the domain given, right? So here we are given the domain from -1 including -1 and 5. So it should be continuous in the given domain. So that is the restriction. And how to find is that you need to find the derivative of the function in the domain, and wherever the derivative is equal to 0 or it does not exist, so these 2 points, which are called critical numbers also, critical numbers, so find those critical numbers. So critical number C, for example, right? So first you should ensure that the function is continuous in the given domain, and then figure out what are the critical points in the given domain, and then find the values of extreme values. So let us say conditional in the domain, let us say the domain is from A to B, right? So from A to B, both included. In that case, then you find what is f of A, what is f of B, and what is the value at those critical points, right? They could be more than one critical point, right? All these critical points. Then you compare these values. The highest value will be the absolute maximum, and the lowest will be absolute minimum, right? So that is how you need to find the absolute maximum or minimum for a given function in the given domain. Now, in some books, they say it should be differentiable, right? Instead of continuous, but that part is wrong, because I'll give you an example which is not differentiable in its domain, but it has an absolute minimum, right? So important thing is it should be continuous, right? It may or may not be differentiable. Okay, now in this video we are not really finding the absolute maximum or minimum, but we are only trying to give you or to understand whether we could apply this algorithm or not. In the next video, we will see how to find absolute maximum or minimum. So let's look into the given questions. So first one is L of x equals to 2x minus 3. it is a continuous function. The domain is -1 to 5. So this function, we could find the absolute maximum minimum for this function, right? So that is not a problem at all. So it says state the reason why the absolute maximum minimum algorithm can or cannot be used to determine absolute maximum and or minimum values of the following function. So here we can find there is no restriction. It is a continuous function in the particular domain, right? Now it may not have any critical point within that interval. That's a different story, but at least we know that it is continuous, right? So for example, you will do like this: L dash x for this is the number 2, and since this cannot be 0, there is no critical point, but you can always find the value of function at -1 and the value of function at 5, correct? Once you calculate these values, -1 gives you -2, -3, which is -5, and +5 will give you 10. Let me write 2 times 5 minus 3, which is 7. So 7 is your absolute maximum and -5 is your absolute minimum. So you can use your algorithm and find your answer. Okay, part B here is a function r of x, absolute value of x minus 1, and the domain I've kept same for all these questions, right? Now this particular function x minus 1 is continuous, right? It is kind of, let me sketch here to show you, because it is controversial. Now at this point 1, the value is 0, right? So that is how the function will look like. So it is going to be 0 at here, and it is not differentiable at this point. It's a corner, right? So it's not differentiable. So this definition where we say differentiable is not quite right, okay? That works only for polynomials, but not for functions in general, okay? Now here, it is not differentiable, but here we have a minimum at 1, and that's absolute minimum, right? So we will say that we can actually find absolute maximum minimum for B also, since it is continuous during its interval. Is it okay? Now, second part, and the derivative here f of c, when you find f dash of x does not exist, that point is at x equals to 1, right? And that is an absolute minimum, as you can see, okay? Now here, if I substitute -1 or 1, the denominator is never 0. So this function does not have any restrictions, and it is continuous within the given domain, right? And therefore, we can use our algorithm to find absolute maximum or minimum. In this particular question, in this domain, -1 to 5, if I substitute 3 here, then the function has a vertical asymptote. So it is not continuous in the domain. So this is the function where we cannot find absolute maximum or minimum using our algorithm. And the reason is that it is not continuous. And therefore, what we could say is, to do such a question, important criteria is a function being continuous in the given domain. If the function is continuous in the domain, you can find absolute maximum minimum. Otherwise, you cannot, right? So these two methods are how to find. This is how to identify whether it can be found or not using the algorithm. I hope the concept is clear. Thank you and all the best.